Turkish defense technology has reached a new milestone with the integration of Aselsan's MURAD Active Electronically Scanned Array (AESA) radar into the Bayraktar Akıncı combat drone. Baykar recently announced the successful test flight, marking a significant leap forward in drone warfare capabilities. This technological upgrade enhances the drone's ability to operate in complex environments, improving situational awareness and target acquisition across multiple domains. The MURAD radar allows the Akıncı to detect and engage ground and naval targets beyond its direct line of sight, surpassing the limitations of traditional optical sensors. This feature significantly boosts operational effectiveness in scenarios where visibility is hindered by weather or terrain. The test was conducted on the Akıncı A variant, powered by AI 450T turboprop engines. Prior to this, the MURAD radar had been evaluated on an F-16 fighter jet, proving its compatibility with Turkish aerial platforms. Video footage from the test showcases real-time radar imaging transmitted to the ground control station, demonstrating its precise tracking and targeting capabilities. Built using gallium nitride (GaN) technology, the MURAD AESA radar brings next-generation detection and targeting abilities. The system functions in both air-to-air and air-to-ground modes, offering enhanced mission flexibility. Its air-to-air capabilities include missile guidance, long-range target detection, helicopter tracking, and weather monitoring. For ground operations, the radar provides synthetic aperture radar (SAR), imaging, moving target detection, fixed target tracking, and high-resolution mapping. With this integration, the Bayraktar Akıncı expands its combat role. Previously, drones relied on electro-optical and infrared sensors, which have limitations in adverse weather. MURAD enables the Akıncı to operate effectively even in challenging conditions, ensuring reliable target detection and engagement. Furthermore, the ability to carry and launch air-to-air missiles such as Gökdelen, Bozdağ, and Sungur further enhances its role in aerial combat. Aselsan confirmed the success of the test on the X platform, highlighting that the MURAD 100A variant represents a breakthrough for Turkey's defense sector. Turkish defense officials emphasized that integrating this radar positions Turkey among a select group of nations with such advanced drone technology. The collaboration between Baykar and Aselsan underscores Turkey's commitment to defense innovation. Initially developed for the Turkish Air Force's F-16 modernization program, the MURAD radar has now proven its adaptability for various aerial platforms. It is expected to be integrated into a range of advanced aircraft, including the Hurjet jet trainer, the AN-K-3 stealth drone, the Kızılelma unmanned fighter, and the KN national combat aircraft. This strategy aligns with Turkey's goal of creating an interconnected autonomous aerial fleet capable of responding to modern battlefield requirements. The MURAD 100A radar incorporates state-of-the-art features such as multi-target tracking, electronic warfare resistance, high-resolution ground imaging, and simultaneous air and ground surveillance. These capabilities significantly enhance the effectiveness of Turkish aerial units in both reconnaissance and combat operations. Following its integration with the Bayraktar Akıncı, the MURAD radar will also be deployed on F-16 fighter jets as part of the ZGR modernization project, which aims to upgrade Turkey's F-16 Block 30 aircraft. Flight tests for this program began in 2024, moving toward full certification. Meanwhile, Aselsan is also working on the Fulmar 500A, a long-range airborne maritime surveillance radar, expected to be operational within 3 years under an agreement signed at IDF 2024. This technological advancement allows the Bayraktar Akıncı to engage targets beyond visual range (BVR), a crucial capability in modern air combat. The radar significantly improves detection and engagement of enemy aircraft at extended distances, reinforcing Turkey's air superiority strategies. Additionally, the Akıncı's increased ability to carry precision-guided munitions expands its effectiveness in air-to-ground missions. The success of this radar integration represents more than just a technical breakthrough. It is a key step in Turkey's broader initiative to develop indigenous defense technologies and reduce reliance on foreign systems. By incorporating AESA radar into high-performance drones, Turkey solidifies its position as a global leader in unmanned aerial combat technology. This progress not only strengthens the country's defense capabilities but also enhances its competitiveness in the international defense market, opening new avenues for military exports and furthering its strategic autonomy.